We present our work development of an intelligent personal assistant for academic advising by Inigus Carrillo and Gaten Lugo with ID number 9654. This paper presents the development of Smart Tutor, an IPA to advise university students for academic advising and frequently asked questions. The tutor seeks to provide a natural, user-friendly interaction to simplify the process of gathering information. For that reason, voice interaction is implemented. The aim of using voice as a means of interaction is to offer a faster, easier, and more enjoyable way to make inquiries. These interactions should be as intuitive and natural as conversations between two humans. In order to verify if the Smart Tutor is usable, we apply Savo, an instrument to evaluate the usability of an IPA that uses voice as the primary means of interaction. Implementing this IPA prototype is particularly beneficial for engineering students, who are frequently involved in projects demanding efficient time and resource management. Using an IPA allows them to manage their activities more effectively, streamlining the acquisition of academic information. Given their knowledge of emerging technologies and their ability to conduct critical analyses, engineering students can provide valuable feedback that helps optimize the functioning and features of the IPA. The global speech and voice recognition market is expected to reach approximately $83 billion by 2032, starting from $20 billion in 2024. IPAs are used in various contexts: in customer service, as travel assistants, in assistive technology, such as therapy assistants for senile dementia, and in smart buildings for device control. They are also used for home automation. And, of course, in the field of education and academic advising. Various studies have highlighted the importance of academic advising in the lives of university students, where through more personalized attention, academic advising provides information, training, and guidance on their educational process. A tutor is a professional with experience and knowledge in a particular field, willing to share what they know through teaching, skills training, advice, feedback, socialization, etc., to facilitate the intellectual, academic, personal, or professional development of a less experienced individual. Since 2011, Universidad de Guadalajara for Review has operated an institutional tutoring program, which is an institutional program of support, advice, guidance, and follow-up for students that promotes their comprehensive training, contributing to the achievement of institutional objectives, with ethics and responsibility in transformation and social development. Individual academic advising is usually assigned in cases of students with scholarships or students with failed subjects. The variety of reasons why a student receives tutoring is so diverse that it is common for situations to require specialized attention. Therefore, even though sometimes group tutoring is assigned, the tutor must switch to individual tutoring according to the case and the needs of their tutee. Many of the requests that a student receives could be addressed with the help of an IPA, as most of them are questions about administrative processes. Thus, with the help of this technology, the tutor could focus on situations that require more personalized attention, making the tutoring even more effective. Prototyping development includes 4 phases: conceptualization, development, testing, and refinement. To have a more natural conversation, it is necessary to implement elements such as greetings, farewells, hello, and trivial chat elements. The main flow of the conversation begins with the user, who initiates the conversation. The phrase the user mentions is interpreted as an intention. These intentions can be questions, control phrases for the assistant, a greeting, information requested from the tutor, or trivial sentence statements. The tutor interprets the type of intention and processes and provides the user with a response according to that intention. Conversation control returns to the user to continue asking the tutor questions. The architecture of the assistant is a conceptual model that defines the structure, components, and their interaction within the Smart Tutor. The Smart Tutor is integrated into a web service to interact with users. To use the University Tutor, students interact through the user interface via browser. Audio is recorded, sent to Amazon Lex, and a response is played back. The AWS SDK for JavaScript was used to capture voice input in a browser and send it to Amazon Lex. The AWS SDK enables Amazon Web Services by providing a set of consistent and familiar libraries to JavaScript developers. The user interface is developed in HTML, JavaScript, and CSS. On the home interface, the icon of the university is displayed, embedded in a circle, a button that activates the assistant. To start a conversation with the tutor, the user must click on the icon, which changes the tutor's state to listening. The assistant has 3 states. Listening state: in this state the assistant listens to and processes the user's requests. Speaking state: here the assistant is speaking. On standby state: in this state the assistant is on standby, so the user must click on the icon to interact. The tests were carried out in 2 iterations. The first iteration was through a pilot test to find the most superficial errors, identify improvement areas, and search optimization opportunities. This test chose a non-probabilistic sample of 27 telematics engineering students. They used the Savo instrument, a tool for evaluating technology that uses voice as a principal medium of interaction. An information session was conducted via the Google Meet platform. A brief presentation of the study was given, consent was requested from the participants, and instructions for conducting the activity were provided. These instructions included: 1. Logging into the assistant's page, 2. Asking questions to the tutor, and 3. Responding to the Savo instrument. A second iteration was carried out after making the necessary modifications to the prototype. This test included 111 students from 3 engineering programs, telematics, biological systems, and geophysics, all from Universidad de Guadalajara. The procedure for the second iteration was the same activity applied in the pilot test. This work describes the development and evaluation process of a prototype for an intelligent personal assistant designed to enhance tutorial attention for engineering students at Universidad de Guadalajara. The conclusions are that in a voice interaction, the user maintains constant attention to the conversation. And IPAs must be capable of recovering from errors and providing the user with a sense of control and confidence, preventing them from feeling lost during the interaction with the assistant. The assistant must maintain natural language with the user and response in time. Ideally, the conversation should flow without prolonged pauses. Additionally, it should be able to interpret different ways of requesting a process. The prolonged use of the prototype is expected to reveal further benefits for engineering students and teachers. Thanks for your attention.